My name is Peter Solander. I'm head of the technical infrastructure monitoring at CERN. Technical infrastructure is everything which is services for the accelerators, like electricity, cooling, ventilation, safety systems and so on. Our job is to manage corrective maintenance. To do that job, the operators have alarm screens and synoptic panels in front of them. Alarms indicate problems somewhere on CERN's site, and we get approximately 1 million alarms per year. So it's the job of the operator to go through the information and pick out and diagnose the real problems. The sites are quite big. We have the big accelerator, which is 27 kilometers around. Sensors are all around the CERN sites, and the control system federates all the information to the control room to give the operator a single view of the alerts. It is really important that the alarms that get through can be trusted. It's important that we get through every alarm that happens on the sites and that we can trust what we see on the screen. So we depend on a system developed here at CERN, which is called TIM, which connects to all of these different sensors and federates the information for the control room.
My name is Matthias Breger. I'm a software engineer at CERN and responsible for the technical infrastructure monitoring service called TIM. TIM is a monitoring and control solution developed at CERN for the TI operators, which works in the CERN Control Center. TIM is built upon a clustered server technology, which we call C2MON. C2MON itself relies on a distributed cache, which we get from Software AG and which is called Terracotta. We have in total 130,000 different sensors for TIM, and all of this data need to be delivered in real time to the client applications. In our environment, we use Terracotta to store all live data, the latest value of our live data, in a distributed cache. When we did the evaluation for our server, we looked already on the future scenarios, like having big amount of data and how to deal with that. And there we came up with the Terracotta solution, which allows us to scale our service horizontally in the distributed cache, but also on our server level. The C2MON concept is so modular that we can really easily adapt the server to different monitoring scenarios. My colleague Mark Brightwell will show you now in some screenshots how the data comes through the system, through Terracotta, to the client applications.
Well, I'm going to show you the Terracotta developer console, where we can see the data arriving in the system, the requests made to the cache, and then an example of our own product, view in our product, where we can see the data arriving and animating symbols. Well, so the Terracotta console shows us lots of information about the cache and how it's behaving, how our servers are dealing with the updates. For instance, the red line you see here on the top left is simply counting the number of cache transactions per second. So the cache contains the latest values for all the sensor data. It's being, of course, constantly updated, but it keeps them in memory and then distributes them to the clients. One of the client applications is the TIM viewer that we see here, with customized views displaying the data for the operators. In this particular case, what we're seeing is water pumps switching on and off to bring down the level of water in the tunnel when needed. So the added value of Terracotta for us mainly is the high availability, meaning that we guarantee the system will be available 24 hours a day, and the operator will be able to view the latest data in his views.
So what we're seeing with the new system is that it's more available. The availability has gone up, which is really important for us. We don't need to call the support group as much as before, or at all even. And any maintenance work can take place transparently now while the system is running.